For our next episode of M squared, M cubed, or 2, Mrs. M's Math to the Masses in a minute or two, we're going to look at probability starting with sets and sets notation. So at the top here where it says a set is a collection of distinct objects. Each object in a set is called an element of the set. A set is denoted with braces. So I'll draw them here. Sometimes we refer to these as brackets, but brackets in math is actually a broader category. The set with no elements is the null empty set. You can use either term, null or empty. Set is denoted by the null figure or empty braces. The set of all elements under consideration is the universal, important word, universal set, denoted by U. You're going to see this symbol and have to recognize the vocabulary. Uppercase U represents the universal set under consideration for any problem. So identifying the number of elements in a set is important for calculating probabilities. So here, if we were going to say set A is prime numbers less than 10, we might need to go back and look at some vocabulary. You're going to see some things. Remember, a prime number is a whole number, it's greater than 1, and the only factors of a prime number are itself and 1. But now I just mentioned whole number. I want you to see this graphic. This is on your resource page. Okay. If you start with natural numbers, whole numbers like 1, 2, 3, 4, which we refer to often as counting numbers, natural numbers, counting numbers, it is within the group of whole numbers, which includes 0. Okay, all of those numbers are integers, but integers also embrace negative numbers. So if you come up here, look, we also have integers would be adding -5, -3, -2, 0, 1, 2, 3, 4. So if you can remember back years ago when we said there's only positive numbers when you're in elementary school, and then you get to junior high and say, oh wait, there's negative numbers. There's lots of surprises along the way in math which give us more and more ability to analyze and work through real situations. So here, set A is a set of prime numbers less than 10. 2, 3, 5 would also be a prime, and 7. So what are the number of elements in this set? That's lowercase n means number of, and here's set A. There's 1, 2, 3, 4 items in the set. So here we're going to put a 4. Let's go to our next slide. Let's say that set B is a set of even natural numbers less than 10. If you need to reference your chart again about natural numbers, even numbers less than 10, you can always pause the camera and take a look. So we're going to put 2, 4, 6, 8, and again 1, 2, 3, 4 elements in set B. Set C is a set of natural numbers less than 10 that are a multiple of 4. Well, that only gives us 4 as a multiple of 4, goes into itself once, and 8 is a multiple of 4, goes into it twice. So how many elements are in set C? Number of elements in C? 2. And the universal set is all the natural numbers less than 10. So let's go ahead and detail those here. 1, 2, 3, 4, 5, 6, 7, 8, 9. That gives us 9 elements in the universal set. This is important because you're going to learn, as we do probability, it's all about considering the part we want to look at compared to the whole we were considering. The whole will always be that universal set, and the part will be whatever they've asked. We're basically setting up fractions. You can turn a fraction into a decimal, and a decimal into a percentage. This is a great unit for street smart kids because they know the odds of getting out of any situation or winning any lottery. They just intuitively get when we talk about what are the odds. Okay, so let's move down our page. And it says the following table identifies terms used to describe relationships among sets. Use sets A, B, C, and U, which we just notated above. Complete the example column by drawing the Venn diagram, then include the elements of their associated sets. So we're going to need to reference back up here. I'm not sure how well the camera's going to like that movement, so I think I might need you to open up your keyed notes or have written this down. So I'm coming down here. Set C is a subset of set B if every element of C is also an element of B. So we write the notation C, we put a U on its side for subset of B. That is right. C is a subset of B. This shows you C is inside B and both are within that universal set. So the example would be 1, 3, 5, 7, 9 are part of the universal set that were not nested here. C only had 4 and 8, but that was held within B, which had 2, 6, 4, and 8. So right there in that box, we've taken the whole universal set, but we've first put C in the inner circle. B contains C plus 2 more elements, and the universal set's completely listed. That's how we would show C as a subset of B with the examples we started with. Let's go to intersection and see what that term means. The intersection of sets A and B is a set of all elements that are in both A and B. So I'll write intersection. And again, we're referring to the numbers at the top we started with. Intersection would be written an upside down U. That means A intersecting B. It's a double-shaped region. So where they overlap is the intersection. All the other numbers of the universal set are outside of it. So 1 and 9 will be the ones that don't fall within. But if I put my A to the left and my B to the right, I'm going to say they both include the element which is the number 2. We have 4, 6, and 8 that were included. And I actually think I just put B is over here. This is B. But A had 2, 3, 5, and 7. So here's my A, my B. The next thought I want us to consider is when we do A, we do the letter U, B, and this is A union B. So I'm going to write the word union. The union of sets A and B is a set of all elements that are in A or B. So again, we have A union B is the entire shaded region. So you see how everything got shaded versus above it. We were just talking about this darker area, the intersection, which was the number 2. So now A union B will be everything here. When I go and write that, 1 and 9 are the only 2 that aren't used, but we have 3, 5, 7, 2 is still here, 4, 6, 8. But we are considering, let's see if I can find a highlighter nearby. Maybe not the color I want. This would work. A union B are all these values together versus the intersection here was that. And the subset C were those values. I've highlighted in yellow each important distinction. Okay, we have one more to look at here on this page. It's complement. So I'll write the word C-O-M-P-L-E, complement. And it does have an E right there. And we write this A with a little C above. There's actually many ways in my other notes on how you can do this. This is what we happen to see. There are some old notes that have the negation symbol we used in the logic unit, because truly the complement of A is everything from the universal set. Well, let's read it here. The complement of set A is a set of all elements in the universal set that are not in set A. And so that's why someone had put the negation symbol to show not A. But I've never seen that in a textbook or something that's true. I think it's just a shorthand by the teacher that did do that original key. So here if we write it out, we have 1, 4, 6, 8, 9, because those are part of the universal set. AC is the shaded region. So let's go here. What is in A is 2, 3, 5, and 7 from our example. So the complement of A, I'm going to put in yellow, are these numbers here at the top. They are in the universal set, but they are not in A. They complement it because they complete the universal set for the problem. But again, your answer for the complement is what I've highlighted in yellow. 1, 4, 6, 8, 9. That's set notation we're going to need to move forward.